Okay. Well, for people who are joining us on the live stream, there's actually a little bit of a different meeting from many that we've had in our series here. This is a status meeting for machine learning, which will talk about various things we're developing. So let's launch. Okay, so first thing we have here is this whole business about formats for machine learning. And I guess the winner seems to be of things that we're going to develop in the future is ONNX. Is it pronounced ONNX or is it pronounced Onyx or something?
I have no idea, actually.
Let's pronounce it Onyx. It sounds cool.
Yeah.
But so that's being built deeply into MXNet. Is that true?
So MXNet has full support to that, and Amazon is one of the major sponsors now of this format. And then also PyTorch, Cafe2, and Microsoft CNTK support it. They were the original ones that pushed this.
And how faithful is the representation of a typical neural net in this format?
So the one thing that's quite different for us, at least, is that encoders don't get attached to this.
Right.
So it's obviously just
right. It's the raw network. Right. Yeah, so our own WLNet contains the encoders.
Yeah.
Okay. So we had a project to make protocol buffer, some kind of protocol buffer IO system like 2 years ago. Do you know what happened to that?
I asked on the neural network mailing lists. I don't think much was, so Tom Wickham-Jones and Abdul responded to that. I don't think they mentioned any previous work on this.
Okay, so I suggest you ask Arnaud and Garrett.
Okay.
Because it was certainly a project that was in the list. I don't know whether stuff was done on it. But explain to me, and the channel framework folk like Igor Bakshi. I mean, this is an alternative to the channel framework. Is that true? How should I think about protocol buffers?
It's similar to
format. It's similar to like JSON.
Yeah, so it's basically designed to be like JSON, but much more efficient because you can binarize it.
Okay. Well, fair enough. So that will turn into an import-export format. Is that correct?
It's a little bit more subtle than that, because when you parse data from an external source, when you produce the sort of binary on the wire format, as it's called, you need to do that relative to a sort of definition, which is called a proto file. So it combines these two things in a way that I don't think is a particularly good fit for import and export.
Why do you say that? I mean, like binary read list or something has a way of specifying the structure of the thing you're reading, an int followed by two, longs or whatever it is. Right?
Does it?
Absolutely. Take a look at it.
As far as I remember, it's missing the kind of recursive stuff, like, for example, an arbitrary list that's delimited by something, or read the length and then read that.
Yes, it is missing that stuff. I mean, that would be more like delimited array and so on. In other words, that would be, this is the type specification. I hate these documentation things where they point you to another piece of documentation. We really should flatten those out. Okay, so here, your point is that you can't say...
There's no grammar. That's
correct, right. But we perfectly well could turn this into a grammar.
Mm-hmm. And indeed, like, interpreters has already generated a lot of that grammar.
Right. So, I mean, if that's what you're talking about, I don't think that's incompatible. And Shadi, maybe you can say something about this with the kind of design we have for import-export stuff.
I agree. Shadi? Compatible. Okay.
All right. Anyway, so let's figure out what's that? So there's presumably some template file for these protocol buffers, and then there's the actual, read according to that template file in protocol buffer format.
Sure, but do we have examples of import and export where it's parameterized in that way? There is no protobuf.
Yes, I think so. I think there is. I mean, I think there are things where I'm trying to remember here. Maybe Shadi, maybe you can comment on this. Aren't there things where you basically are giving in the element specification, you're giving a structure that is what you should read?
Not really. No. not a structure. We do have partial access in a lot of the formats, but not a structure specification.
All right. Well, so maybe this is, I mean, maybe it's something slightly new, but it's similar to binary read list, I think.
Yeah.
Well, why don't you get more detail and then let's do a design discussion about it. Fair? Yes? Tally?
Honestly, I think, yeah. Honestly, it's a fairly big project. I don't to do it well and expose it to users.
So you're proposing to do it without exposing it to users?
I would prefer to do that first, and we sort of gather a bit of experience with that, especially how it relates to Onyx.
Okay. Fine. Okay. Let's keep going here. GPUs, etc. Okay, new models. Cool. Can we see them? Let's take a look. How is the post, by the way, about the neural net repository doing?
So we've actually not written the post yet. So we're still.
I've noticed that.
Yes.
By the way, why did this load wrong? That loaded like that. I think if I reload, it'll come out okay. But the first load was wrong.
That's weird.
Okay, so what am I looking at here? So there's new neural nets, 7 new models.
If you scroll all the way to the bottom and just click on the all resources, there are 3 new. I'm not sure how to pronounce it. Atom X app.
Okay.
There's 3 dilated ResNet models.
Why don't we start putting dates on these? Seems to me we should start, so we can have sort by date here.
Well, I agree. Sorting by recency is good, but the dates seem like they might clutter it quite a lot. I don't know.
Well, we don't necessarily have to put the date everywhere, but in this, I think certainly in the actual shingle here, we should put the date.
All of them start with when they were either developed or released. So in the
right, but I think we should say when they were added to our thing because I think it's very unembarrassing.
Should we distinguish between submission date to the repo and release date of the model?
Yeah, what we want to talk about is release date on the repo.
Mm-hmm. We do have that information within the resource object, but it could be we could ask to have it on the actual website.
Yeah, let's surface it.
Yeah,
and then let's also say browse by recency here.
Where should the date go? Should it just go maybe just underneath the?
At the very end, I would.
Yeah, I could go at the end. Why not? Yes. Requirements, okay, or above. All right. So I think it should be. Look at how it's done elsewhere. In demonstrations, we just added a date thing. Even though demonstrations go back 10 years, we hadn't been putting those dates on. Make sense? So do it the same way it's done for demonstrations. And there's a new format for demonstrations that was recently added. Make sense?
Okay. Sure.
Cool.
Okay. So
can I briefly ask about the resource object? Why do we show that sometimes and not other times?
We always show it.
Do we always show it? Oh, okay.
Yeah.
Okay. So what are these new networks?
6 of them are semantic segmentation. CapsNet is classification. It's like LaNet, but
capsule network
is different.
Oh, it's the modern capsule network thingy dingy.
Yep.
Yeah. And the deep speech one is up there too.
What is that pic? Oh, I see. That's the name. So that is a non-compiled raw MXNet thing.
Yeah.
It's a placeholder until it'll be supported in the next version.
Right. But by the way, if I might say so, it seems foolish to have the thing that is the most obscure be the most bright in this picture.
Well, the original goal of that was to make sure people didn't accidentally deploy them to the neural net repository, which was exactly what we deliberately did here. So,
okay, why don't we make that color like our standard pink color?
Sure,
rather than this ridiculously bright. I mean, I understand it's a warning, but it's also an emphasis. So this works, is that right? And what does it look like if I were to? Okay, here we go. So you're saying if I run this right now, And why is this not loading in? Oh, there we go. Is it big? Is it big? Oh, it's only 32 megabytes. Why is it loading so damn slowly?
Not sure.
The Packlet updated in the background. I noticed that was one of the.
Oh, okay. What on earth is this? What
I mean, we could try to hide the guts of the function, but we're not supposed to.
I don't think we need to hide the. Why don't we just have it raw rather than having all kinds of backticky things?
Sure, yeah, like format
just the raw code. Yeah.
Well, I mean, that is how the code would look if you got it out in the notebook. But
I understand, but why don't we at least have it with the?
Yeah, I can do a formatted version of the code.
Yeah, something a little bit nicer than that. But maybe with a background color to indicate that it's not. Well, what do we want to do? Sorry, Etienne, you were going to say something?
No, I was a bit scared by seeing some neural networks backtick private. Like this won't be backward compatible.
It's not documented. Like this shouldn't be here at all. It will be gone in the next version, right?
Okay,
like this,
fine. So I don't think we should display it. It should be right. What's going to happen to this net model in the next version? Do you understand what I'm asking?
So basically what happens is that we have versions for content elements, for resource objects, and so there'll be a version 2.
Okay, fine.
And that'll be automatically downloaded. Yeah.
Cool. Okay.
And what's funny is that for training, you don't need this custom layer. It's only for the evaluation part. So the training is perfectly.
Okay, so we're fixing this, and it will be fixed.
By the way, Megan.
Yep.
Did we put already the find textual answer network?
No, that hasn't gone up yet.
Okay, it doesn't have a page yet, right?
No, I mean it's non-discoverable right now.
It's there, but it's not linked.
That's a cool one to.
I think so too. Yeah.
Oh yeah, definitely. If we're ready to submit it, it can be submitted, and we can. I just basically need an example notebook and a construction notebook for it, and then we can publish it on the repo.
Okay, that's a Jerome issue. I mean, Jerome wrote that very nice blog post about it. Surely he has that stuff. And also we should point to, by the way, that's something I'm not sure if we're doing that, Megan, is point to Jerome's blog post when it comes to discussing that network, right? The shingle should point to his blog post.
Mm-hmm.
Yeah,
so the reason we actually put this on. So the reason we didn't actually put this on for now is that it requires a lot of MX layers, and we're not sure if we're actually going to represent those in the future, which means that this network might break in the future because MX layer might change. So we're a bit worried about that.
Could we have a banner? Like we have experimental functions, we have experimental networks. I don't know.
It's a possibility. Okay, we'll think about that, yeah.
Okay, all right, let's move on here. Polish the YOLO2 network. Is that related to image cases?
Yes. Yes, we want part of it on the repository as soon as possible.
Okay.
But it was exposing some internal stuff. So Matteo helped me rewriting some layers to avoid some internal options. So it's now it will be better on the repo.
So 10 models in the SQA queue. What is the sequence here? Is that there's a
Actually, I was wrong about that. I thought the segmentation models were still in the queue, but they've actually made it to the front.
So Megan, what is the process here? Do you send the stuff through SQA, or are you sending? Who's doing QA on these things, and what are the continuing tests that are maintained?
I send it through DQA. So I get a submission, I approve it, I put it all together, I make the internal shingle, I send it through DQA.
But what's the actual SQA aspect of this? I mean, we should be testing everything in the repository should be tested. Like when we get to beyond 11.3, right? The next version. I mean, there should be tests generated for these things.
Exactly. So there's actually a list of things to do with QA is to have proper testing. I mean,
I think Megan and you should probably talk to Raj and figure out how one gets a systematic testing process for these.
Sure. So actually, yeah. So we've been in discussions with Raj to revamp the entire testing procedure as well, because at the moment there's no testing that happens on GPUs automatically.
Oh gosh.
But there's there's a custom running.
How many GPU variants are there that we have to test on?
I don't think that's a major thing.
Yeah.
I think a low memory one and a big memory one is enough.
For now, until Intel and AMD release their competition in the solution.
And what about things where people can have different versions of libraries installed? Can they, or is that not different revs of the Intel chipset and things? Do they allow different libraries?
Well, we ship the CUDA, so there's no variance there. There is graphics driver versions, but
I don't think that's relevant. Yeah. So this is complicated. I mean,
this is for different operating systems. Like that also is a potential thing. Like it might work on Windows, but not Linux.
Yeah, but that we do, those tests we do anyway, except the thing we're not doing is that matrix going across different GPU configurations, I think. I mean, I don't know exactly what. I know we're doing that by hand, but I don't think that's part of the automated nightly regression tests, is it?
No, it's not. Exactly. So that's what we're setting up now. So we're getting GPU machines into the automated testing.
Okay, good.
And yeah, we should definitely have a test for this as well. And it has to obviously test on GPU plus CPU and make sure that it doesn't change in the future.
Right. Okay. Data sets. What is this thing?
The Microsoft Cocoa. There was a new version released late last year that I'm working on importing into MongoDB for us.
That's for internal use, or that's for okay. Mm-hmm. What is a resume feature for the uploader? That's the S3 uploader or what?
Yes, is something that we didn't have time to add before we were like fixing other things. It would be nice if we could upload the big data set in like multiple chunks, given that sometimes we have errors or things like that. It's basically to save Megan time in order to, instead of like restarting from the beginning every time.
Okay. Images. Okay. Another data set.
That is a big data set for image object detection in images that we should have in our Mongo database.
Good. Okay, so listen, let's move on here. Speech recognize. Okay, cool. So can you demo this?
Yeah, I mean it is the first version of the network, so it is very slow, but it does something. So.
Okay. Should we let you share your screen?
Sure, why not?
Okay.
Is this using the fixed beam search, by the way?
I hope so.
Okay.
This is the last version that Tim sent. Okay, so this is the signal that hopefully will not crash the kernel. And
right, perfect time.
Could you hear the?
Yeah, more or less.
Okay.
You're not sharing audio, though.
Really? I should have been.
No, I can see your screen.
Okay.
He can also share his audio.
Yeah.
His computer audio.
Oh, okay. So I assume it didn't work. Anyways, it's just male voice that says.
No, I heard it.
Yeah. Okay. So right now it is quite quick because it is cached, and I already evaluated this.
What's cached?
The various steps of the recognition. We have first a feature extractor.
Well, why don't you do an audio? I mean,
yeah.
Does it handle your Italian Scottish accent?
Hello, my name is Carlo. Let's see now if it does anything. And as I said, right now this is the first version of the network, and it will Kaba.
This is the language model.
But no, wait a minute. Where's the language model? I mean, hello shouldn't have been wrong.
Yeah, no, the language model is off by default, and currently we just have this option to activate it. And so
it's definitely more English.
Yeah.
This language model also, like when it's better, it'll know more names. Like it probably hasn't been trained on any names yet.
Yeah.
No, really, it's.
I mean, is it only trained on the TED data set?
That's it.
Okay, so it is tiny. Anyways, it works. It does. We can do some limited separation of words and figuring out at which time they are pronounced.
This is great. I don't think that's the right way to present this.
No. So this is completely not final. This is just a way to get the results out to test the network, essentially. This is definitely not the final output form.
Can I see the network? Can we see the network?
For sure. If I remember.
It's probably on the net repo, actually.
Yeah. Yeah, actually, do you have the name handy? Tim?
Yeah.
Well,
I'll try. No.
I'll just put the link from the repo. Hold on a second.
Okay, and you can test it on your machine as well, Stephen, given it's in the net model.
You mean I can actually run it?
Well, you can download the network, and there is some evaluation function that goes with it.
There's a web page for it. So it's Deep Speech 2 trained on Baidu English data raw model. So if you just type in Deep Speech, you should find it. And two words.
Well, how is that search working, Megan? Is that search working decently or not?
Yeah, it is.
And that should be expanded.
I mean, it really depends on whether you have good keywords in there or not.
Okay, so this is, why is this going so slowly? Again, a question for Megan. Do you know why this download is so slow?
No, but I think somebody just mentioned that it is updating in it updates if it finds a new model. So I don't know if that has anything to do with it.
No, but this 200 megabytes should be coming in a snap with my network.
Do other cloud objects download that fast?
I think so. Megan, I think you should investigate this. I think there's something wrong. And that will be a question for Brad Ashby and Bob.
Okay, yeah, I'll ask.
Resource system. Okay, so, oh, for goodness sake, what's happening here? So okay, there we go. So this is that network. And what you're saying is if I do an audio capture here.
No, you need the evaluation function. The reason that it's called raw model is our current audio encoder doesn't support this thing, but it will for the next version.
This. I have to have this.
Exactly.
Okay, so
for now, and we call it raw model because the final thing will be there later on.
Hello, let's see if the speech recognition works.
So this has no language model, right? So
yeah, there's no language model.
Let's see if it can deal with. Okay.
You can just do net evaluate of that audio object.
I'm sorry, net evaluate of what?
Of the audio object that you just recorded.
Of persons.
What?
It's already grabbing. Yeah.
Somebody was asking on the live stream, what is the deployment process for models trained in Wolfram Language? No, it's not bad. That's really not bad. I mean, obviously, it'll be better if there's a language model. The answer for deployment is you can deploy it in our cloud, or you can deploy it as a raw MXNet file, but then you don't get all the nice encoders and all these kinds of things. Like you don't get to just take an audio object and stick it into, well, this isn't so beautiful because it required code here, but soon you'll be able to just stick it into this neural net and have it work. And by the way, you can use a lot of this stuff for free on the web if you're wondering that. Okay, but let's talk about speed here. Why is it comparatively slow, and what will make it faster?
So there are several improvements in the neural network itself that will make it faster. What we are doing at the moment is we resize the network in order to take the length of the audio sample that you provide every time.
So the problem is we don't currently support variable length for convolutions with padding layer. So this is a feature that we're currently adding. That means that this thing can't run on variable length. So yeah, as Tim says, you have to, that code, that evaluation function, there's a resizing operation, which is quite expensive.
Okay.
But that will be gone in the future. There's other things as well. So things like our CPU performance will go up dramatically in the next version when we use Intel's new primitives.
And when we have a variable length convolution also, we will be able to segment a speech signal and do a batched evaluation of the various segments. That will also speed up.
Correction, we do have variable length convolution. We just don't have variable length convolution when there's padding.
And is that stuff packet updatable?
Yes, but yeah. In fact, my ambition is to add this feature, this padding support for variable length convolutions, as part of the bug fix packlet update that we're already preparing for the other issues.
Which is what, on what timescale?
Weeks. A week.
1 week?
Yep.
Okay, cool. All right, well, this looks great. I mean, this is starting to work. I'm sorry, what's the story with the language model? What's the...
So during the decoding, actually what the network outputs, it's a probability for each character. And the language model acts as a separate expert at every frame of the audio signal. So the acoustic experts say, I believe this is this character. And the language model say, well, my feeling, given what we saw previously, is more like this. And eventually you mix the two experts to come to the final decoding.
Okay, but I'm asking, in terms of the development process, where are we at with the language model, and when will we have something that is as good as it can be?
So we already have a small language model that was trained on speech, various speech from TED conferences and things like that, and we are also training on larger data sets and for longer. So we will upgrade language model as it goes.
But doesn't the language model only need the text? It doesn't need the speech anymore, right?
Yes. The language model is only trained on text. It's
right. So I mean, we can either have written text like Wikipedia or something, or we can have endless transcripts.
Yes, but actually, the data set matters a lot because you don't speak like Wikipedia. So if your expert is trying to format everything like a Wikipedia sentence, it won't. I mean, probably for the spelling, but right. you will. It can also modify.
Not everybody talks like a TED talk either.
Yes, that's a point.
So where are we going to get realistic transcripts? I mean, clearly, there are gazillions of from litigation and court records. There are just unbelievable, amounts of transcripts. Again, probably not perfectly everyday speech, but that is just running speech. Where are some other sources of large-scale speech transcripts? That seems like a good one, and we certainly can get. There's a lot of that available easily.
So, well, yes, everything we can have, we can try.
Okay, who is working on that problem of getting the transcript data sets?
I think for most of what's done now, it was I and Sebastian.
Okay. Have you talked to the curation folk like Alan and so on about whether they have ideas for where to get it?
We should probably talk to them. Yeah.
I would recommend. I mean, my immediate, most obvious look. There are a couple of cases. There's things like the closed captioning from television, which we have a lot of and can get even much more of. And then there's, I think, things like the federal court system, records, which will contain. I don't know how you segment off the parts that are actual transcripts from the parts that are, filed information and so on. I don't know where else there'll be, and we should think about where else there is large volumes of transcript data. But I think there's
also put non-transcript data. I think including a part of classic written text.
We can put in all the. We certainly have a data set of all presidential inauguration speeches and things.
Okay,
I don't know whether those are considered ordinary speech, but those are that's.
This won't be much, I guess, in terms of length. But I think putting a piece just to enrich the vocabulary, just to have.
Exactly. Yeah,
there are endless things. What's that?
Very diverse.
Right. So why don't you ask Alan, because that's his kind of area, and see what he can surface of just transcripts of as realistic everyday speech as possible.
Sure.
Well, Stephen, okay. There's a last aspect that will need to be done, I think, with the speech to text that involves some design, and I think it's interesting. It's the post-processing. So as you see here, all the characters are in the small cap A to Z space.
Yes.
The space. And probably we want to put dots between sentence.
Yep.
Commas, capitalize
uppercase letters.
And maybe more importantly, also importantly, if I say $163, maybe we should convert that to, $sign 163 numbers.
Yep.
And it's also entities like names or places they're capitalized as well.
Yeah.
Sure. But I mean, so what has happened with our capitalize function, which, capitalize has some things, has various options, but I don't think it has, let's take a look here. Yeah. So title case, all important words.
Text and it will naturally, but that should probably be a function.
Yeah, standard function.
That is the inverse of spoken string, really.
Yes. Well, wait a minute. What do you mean the inverse of spoken string? I mean, basically, okay. So here's one very simple one. The person at 12 St. James Street, right? And we want to turn that into
Saint would probably be the SAINT. Yeah.
Oh yeah, right.
And street as well.
Yeah, but anyway, but I mean, okay, fine. But I mean, my point is, ultimately, we want to turn it into something like that.
Yeah.
Yeah, that's interesting. I mean, that is a nice machine learning function, I would think.
By the way, if you do spoken string of that, what does it do?
Take a look.
No, of the second one. Of the
okay.
Output.
But this is.
Oh, it doesn't do 12.
I don't think it needs to. 12 is speakable.
Oh, I see.
But listen, this is like colorize for text, right? You take a piece of text and you just lowercase everything. Then you need to reconstruct the non-lowercase version. That's the analog of a colorize function for text.
You also want to add some missing parts. You have some imputation about where to put the punctuation.
Well, same thing, right? So my point is, think about that. You just take a random Wikipedia article, for example, right? So here's my idea for training, right? So let's say Wikipedia data, James, whatever that might be. Let's get the data here, and there'll be some big long thing. Well, let's just say, gosh, that's long. Okay, well, it wasn't actually so long because it's James Street, if there is one. How about Jane Street? That's the name of a hedge fund. I'm sure that'll have something. Oh, great. Okay, well, anyway. Who knows? Okay, it doesn't matter. But in any case, my point is you just take the data and you simply lowercase and depunctuate everything.
Yeah.
And then you want to learn back what the capitalization and punctuation should have been, right?
Exactly.
So it's exactly the analog of colorization for an image.
Yeah, except numbers are the one thing that's slightly harder, but not much harder.
Oh yeah, somebody is suggesting here. It's actually several suggestions here on the live stream. Sports commentaries used as data. That's an interesting one. If those are available in transcript form. Another suggestion is speech transcripts from university classes. I don't know. I assume that there are from MOOCs and things. There may be some transcripts. Well, even if yes, that's an interesting idea. And another one which I was sort of getting at was the transcript of the U.S. Congress, congressional record. The person says they talk like everyday people. I haven't actually listened to it. I don't know. And there's
also Reddit. Oh, sorry.
Yeah, Reddit. I mean, I guess that's right. I mean, these places where people write like they speak, like Reddit. Yeah. So okay, there's clearly some good sources of write like you speak type text. So let's ask the curation team to try and collect some, and let's do some training on that. But I really like this idea of trying to get, the inverse of just decapitalizing and depunctuating everything. And that seems like something we should try. And do we know what kind of network we would try and train for that?
It's typical sequence to sequence training, so something close to translation.
So try it. I mean, you can generate immense amounts of training data for this.
Definitely.
And you want an attention mechanism. That's the main thing that will make this work well.
Yeah.
What do you mean?
So for the sequence-to-sequence example, the attention mechanism allows it to basically look back at the input sequence.
I see. Right.
And for things where it's basically copying out something, that improves massively.
Yeah, I've seen that. Right. Okay. Wonderful. All right. So let's talk about. I just want to skip to the end here, and then I want to come back to the audio identify stuff. Implementing LCC 125. What is that? Is that the big news stuff? Is the big news? Yes. Are you with us?
Yes, it is my stuff.
What is LCC 125?
Normalize a norm update to argument form.
But is that a Jira ticket? What?
It is.
Oh, it's a Jira ticket. Oh, okay. I'm sorry, I was just totally confused. Oh yeah, somebody else on the live stream is suggesting for kind of write like you speak stuff, mailing lists for random open source projects and so on. Yeah, I mean, look, there should be a lot of material here that's write like you speak stuff. Okay. Okay, you're doing linear algebra stuff here. You weren't involved. Konstantin has been doing the hash stuff, right? The new hash stuff, correct?
It is delayed.
No, but it's different project. He's not involved in the Konstantin new hash thing. There was indeed a consistent hash project to do a hash that is both fast and that will be the same for all versions of Wolfram Language in the future. And but this we might actually postpone it because we think that the work that Piotr is doing with raw array is very important. That might become numeric arrays, right? And so if the menu can help in some way, like making MKL function work on raw array, that would be great, and that would help us for machine learning. Since there's many models that are programmed top level, that would be great if they can use raw array instead of packed array. They would gain, probably some speed, but most importantly, some memory.
Right. Okay. So, last topic, and we're running over time, I think, here, is the audio identify stuff. So is this saying you have got an audio identify working, Carlo?
Well, I'm trying to figure out which is the best architecture and the best hyperparameters. I have a couple of architectures trained, essentially some equivalent to image identifier, some equivalent to ResNet with some adaptation to the audio domain. And they seem to do something. They seem to work. And I am trying to...
I mean, so the output is things like dog bark and so on. Is that right?
It's a probability per class, yes.
You could show what you showed us. Some cool graph.
Yeah, you had a nice demo on Wednesday.
Go ahead, show it.
Okay. So, well, assuming that things... Oh, wonderful. Everything is in a bitch ball of doom. Oh, okay. Still... something bad is happening.
Well, we can see the output there. What is...
this is the boring part of the output. This is just the training progress of the last few.
I think if you still have the graph, that would be...
I mean, I do have it, but it is... my computer is non-responsive. If you give me a second, I will restart Mathematica and have it working, hopefully.
Okay, but so let's talk about the pitch identify stuff. So you also have something which is an audio pitch identify.
Well, no, I don't have anything. I have an architecture that I am planning to explore a little bit. But given that I have no data sets that are effective, I just use the sound from Mathematica to generate an audio signal.
Okay, which is really kind of... Okay, so the issue there is... where do we find play each note on a piano, play each pair?
Yeah, so there are several issues. One, there is no architecture that has been proven to work. There is one paper that has had good results, but only trained on piano music.
Okay. Well, why do we think that why do we believe, what do we believe this should be operating on? A spectrogram or operating on the actual raw audio signal?
Well, I mean, the spectrogram is the most safe bet and what most papers use. So that used as feature for the neural network.
Okay, so why do we believe that modern machine learning is going to be useful relative to classical signal processing for this?
Well, none of the two approaches has been completely successful yet. So this is just exploration.
Okay, but for monophonic stuff, it can be done, yes? For
monophonic stuff, it can be done. And we do have some functionality to extract the fundamental frequency. So that is already in the system.
Where is it?
In audio local measurements, fundamental frequency.
Oh, I didn't even know that. Okay. And how does that work?
That is classic signal processing. Just looking at
just starting to support the pitch detect function. What is the pitch detect function going to do?
So the point is, we haven't thought about design of pitch detect because we don't know exactly if it will be possible to have and what will be possible to have. So my plan was to play around with a bit of neural networks to figure out what we can get out of it. And after that, we can have some design.
But I mean, to really have something interesting, we would need to be able to represent musical scores and so on.
Yes? Agreed. So this is a long-standing project that hasn't started yet. Maybe Shadi can comment
even
on
to
the
very basic stuff of moving over all the stuff we did in music theory for Wolfram Alpha, moving that over to Wolfram Language functionality.
So we have had several meetings about this. And Shadi, do you want to comment about the status of?
Right. Both with Mike Winter and Philip Bloom. These seem to be the people internally that could help a lot. Mike left. But grabbing what is available in Wolfram Alpha and just putting it in the language is not going to work. There is a bigger symbolic music framework that we basically have to develop in order for us to be able to really represent music in the correct way in the language. So it is a substantial new development needed there.
And the reason for this is we've got to be able to take a score basically and have some appropriate symbolic representation.
Yeah.
Do people have, I mean, in like Finale and things like that, do they have they have an XML. I know there's a
music XML.
But is it reasonable?
It seems so. And there are several other approaches. Lillipond is a software that generates.
We dealt extensively with the Lillipond folks, some guy in the Netherlands, right? Maybe a decade ago. And very nice interaction with those guys.
Okay. That has an internal representation. Some music library that's called Music 21 for Python has also a nice representation of scores. So there are several systems that we want to analyze. Yeah, right. That's the plan.
But then the end result of that is what we're really trying to do is ultimately is a music recognize that will return some kind of symbolic music object.
Yes. Okay. So what we can do for now, what we would have, if this algorithm worked, we would have audio in and sound out. Essentially, this is the idea behind the whole thing.
But so it's the analog at the moment.
Exactly.
But maybe we should still have a pitch detect function or something like that isn't an obscure piece of audio measurements that's simply, given that just as a repackaging of what's the fundamental frequency of the sound for the simple case.
Okay.
Because I've seen a bunch of people wanting that for all kinds of things that aren't really music related. Like you have a lathe that's turning at a certain rate and you just want to listen for what is the fundamental frequency.
Okay. Okay. That sounds reasonable to me.
So what would we return? So from pitch detect, what we return is the best guess of the fundamental frequency, right?
Yes.
So I mean, if I listen to Maine's hum or something from the, I should get 60 hertz.
Yes.
Type thing.
Yeah, we get it. So out of audio local measurements, we return a time series.
Okay. Okay.
So I think that's still a reasonable result, but if you really want a sound. No, we don't.
Well, I think the case that we want, I mean, there are a couple of different things we might want. We might want we might just want one number. That is, you feed in this thing and you want to know what is the average pitch of this thing. I don't know. I can see a bunch of use cases where you're like trying to debug things and you've got a sound and it's like, what is that? Is that a 60 hertz hum? Is that, what is that? Now, I agree that I think that the time series case is actually a more obscure case because that assumes that's like playing one note at a time I mean, that's cute, but it's more of a novelty item, I think. Now, it could also be that.
The assumption is that the fundamental frequency changes over time. That's why time series.
Yeah, fair enough. Well, okay, so that's interesting. So, I mean, okay, let's have a discussion about packaging that. Whether we want the time series case or the static case is interesting. But I think we should do that, and I think it's a completely separate thing from worrying about things like polyphonic music.
Mm-hmm. Okay, that sounds reasonable to me.
Because I mean, I think there was already a lot of utility to that pure pitch detection thing, and notice that in terms of training, we actually don't want music there. We want it to be trained on weird machine sounds and so on.
Right.
Yeah, I mean, as I said, this is
classical signal processing.
Yeah, at the moment it is signal processing. It seems to work reasonably well.
I think that'll be the right thing. I can't imagine that machine learning is going to help with something which is basically where's the concentration of energy in a spectrogram, basically.
Well, it's not necessarily that easy because, I mean, sounds do have plenty of harmonics and are weird, essentially. Yeah, so it's not as straightforward as that.
What about a sound where the lowest, is it the case that one gets situations in which the lowest, like, I don't know, in period doubling or something, where the lowest frequency is actually not the dominant frequency?
Yes, you do get that. And you do get also that the dominant frequency is not the one with the highest energy. So you have plenty. Well, I mean, so let's say you have one harmonic at 100 hertz with an amplitude value of 0.5 and another harmonic at 200 hertz with an amplitude value of 1.
Yeah, right. Because of the fact that the energy depends on frequency.
Not necessarily that, but you can have more energy in a higher harmonic rather than the first harmonic.
But so then what would you want?
Will be brighter.
But so when somebody is trying to say, there's a rattle in my airplane or something, what is the frequency of the rattle? I mean, won't they want the...
Well, rattles are usually harmonic sounds, so the same applies here.
Which means there's a lowest frequency, which is the true rattle frequency, and the higher ones are just a harmonic of that lowest frequency. Is that what you're saying?
Exactly. Exactly. So, I mean, the point is, you don't want to find the lowest frequency. You want to find the minimum frequency of which all others are multiples of.
I see what you're saying. So your claim is that in physical phenomena, the typical case is there is a fundamental frequency and then a bunch of harmonics stacked on top of that.
Exactly. And the amplitudes of those are can be essentially whatever.
Right. Okay. Look, I think this is a very useful function that has absolutely nothing to do with music transcription.
Okay.
And I think we should try to have that. Let's see. We had... right. Okay, I think that is everything. Somebody asked in the live stream, do you train your models in distributed fashion on cloud machines? Yes. In fact, we're using, have we started using these Volta AWS thingies? Is that what we're doing right now?
Not yet.
When do we get to start that?
That the half precision support wasn't yet finished for the most recent version, but it's high on my list as soon as I'm done with this bug fixing phase.
What is half precision? What do you mean? What is the
16-bit support? That's the V100 tensor cores. The kind of reason to use the Volta cards. The whole point is it's 16-bit, yeah, and it's much faster.
Sounds good. Okay. Anything else from anybody here?
Nope. So if you want, I can share quickly the audio identifier if you have 2 minutes.
Oh, sure. Yeah. Okay.
No,
yeah. Go ahead. I'm late for something. Please. But it's
okay.
The demo. Yep.
Okay. So I have the 2 networks trained used as feature extractors. I run them on our example data that we have in the layout. And this is the corresponding feature space plot in the 2 cases. And as you can see, there is some semantic separation. So all of these IR signals are just impulse responses flute and flute scale are recognized as very similar as piano and piano scale.
That's really cool.
These are human or animal sounds. These are musical instruments. These are mechanical things. So, I mean, this is quite good. We can get it as a time function. Yep.
Sorry, Carlo, just to comment on this feature extraction, this will be a big boost for classify, predict, and
yes, this will be a
high-level machine learning.
An immense improvement over what we have right now.
For the audio case.
Yes, exactly.
This looks really nice.
And the other thing, I tested it on a data set that has 50 classes that is commonly used as a benchmark. The human accuracy on this data set is about 81%. And as you can see, with the features extracted and classified, we do way better than human accuracy.
So this is it a frog or is it an
yes, type thing? Exactly. And this is the feature space plot of that data set. Various colors are the various classes. And as you can see, it manages to separate various classes quite effectively.
This is spectacular.
So it's promising. These are the first tests in terms of training and hyperparameters, but it seems to be promising.
Looks very promising. When can we get that? And do we have the ontology reasonably well cleaned up? Has that been going through the...
Well, Alan Joyce is aware of it. I need to speak with him again because that will be definitely needed to clean up the results because the classes are imbalanced. So,
okay. That was really neat. Very nice. Okay. Thank you all very much. See you all soon.
Bye.